Hello my precious friends, I really hope that you are doing great. Welcome to today's class. It's our second lesson on a given Form 2 mathematics topic called equations of a straight line. So today we're looking at what we call parallel lines, and we'll start by defining parallel lines. So these are simply lines which do not intersect. Lines which do not intersect each other, So this is what we call parallel lines which do not intersect each other. Now, the key point that you need to note as far as parallel lines are concerned is that parallel lines, they usually have equal gradients. So parallel lines have equal gradients. So this is what we call parallel lines. Now let's consider two lines which are parallel to each other. Suppose this is our first line, then of course we have the second line here. So if these lines are parallel, then they'll be represented this way, of course with an arrow. So if I let this to be my line L1, then this to be my line L2, then if these two lines are parallel, then their gradients must be equal. Therefore, we say that since line L1 and line L2 are parallel to each other, it simply means that the gradient of line L1, it must be equal to the gradient of line L2. So the gradient of L1 must be equal to the gradient of the line L2 because the two lines are parallel to each other. Now, an example of an equation could be, suppose maybe line L1 is having the equation of, let's say y is equals to 2x, then of course plus 3. Then the line L2 must be having an equation such as y is equals to maybe 2x plus 5. Such that when you compare these two equations, so the first one is y is equals to 2x, then of course plus 3. Then the second equation is y is equals to 2x, then of course plus 5. If you compare to the general form of the equation of a straight line, which was y is equals to mx, then of course plus c, of course where m was representing the gradient of any given line, it's clearly evident that the gradient of the first line is equals to the gradient of the second line. Therefore, we can say that the gradient of L1, which is equals to 2, is equals to the gradient of L2, is equal to the gradient of L2, which is also equal to 2. So you can see both gradients are equal to 2. Therefore, you can say that the line L1 is actually parallel to the line L2. So two or more lines are said to be parallel to each other if they have equal gradients or the same gradients. Then two, we look at what we call perpendicular lines. Now, when are two or more lines said to be perpendicular to each other? So perpendicular lines are simply, these are lines which intersect at right angles. Right angles. Or you can also say they are simply lines which intersect at 90 degrees. So if two lines intersect at 90 degrees, then such lines are said to be perpendicular to each other. For example, let's consider these two lines which are perpendicular to each other. Suppose we are having two lines L1 and L2. If this is our line L1, then we have another line L2. Clearly, you can see that these two lines are intersecting at an angle of 90 degrees. Now, if we let the gradient, suppose the gradient of the first line L1 is equivalent to M1, then you also let the gradient of the second line, suppose the gradient of L2 is given by M2, then you are saying that if two or more lines are perpendicular to each other, then the product of their gradients must give us -1. Therefore, we are saying that for two perpendicular lines, the product of their gradients, the product of the gradients of two perpendicular lines. So the product of the gradients, the product of the gradients of two perpendicular lines, perpendicular lines is equal to -1. Remember, the word product in mathematics simply means multiplication. So in simple terms, we are saying that if you take the gradient of L1, if you take the gradient of the line L1, then you multiply with the gradient of the line L2, these two are supposed to give you -1. So because we were letting the gradient of line L1 to be M1, it simply means that if we take M1 multiplied by the gradient of line L2 is M2, so this particular product is supposed to give us -1, provided that the lines L1 and L2 are actually perpendicular to each other. Now, examples of such lines could include the following. Maybe the first line is given by, suppose this line has the equation, maybe y is equals to 2x, then of course plus 3. Then the second line has the equation of y is equals to -1/2, maybe x, then of course plus maybe 4. So you can see that the gradient of the first line, if we compare it to the general form, which was y is equals to mx, then of course plus c, we also compare this to y is equals to mx, then plus c. Clearly, you can see that the gradient of the first line will be +2, whereas the gradient of the second line will be -1/2. Therefore, should we take M1, then we multiply with M2, we are supposed to get -1. So our M1 is +2. So if I take 2 multiplied by my M2 is -1/2, that is multiplied by -1/2. This one will give us 2 and 2 will cancel out. So we'll get the answer as -1, showing that the line L1 and L2 are actually perpendicular to each other. Now, the other concept that we look at is the concept of coordinates of the midpoint. So to understand this, let's consider this particular straight line here. Suppose this is our straight line having the coordinates of A and B. Suppose this is the coordinate A having the coordinates of x1, then comma y1. Then of course, suppose this is the midpoint of this particular line, the point M. Then we also have another point B on the further end of the line having the coordinates of x2, then comma y2. Remember, when we talk of the midpoint, it simply means that this particular distance MB is equal to the distance AM. So if M is the midpoint, it simply means that the distance AM, it must be equal to the distance MB. For example, if AM is 2 centimeters, then MB must also be 2 centimeters for M to be considered as the midpoint of this particular line AB. Now, if we want to get the coordinates of the midpoint, so we'll say that the coordinates of the midpoint will be given by the following. Of course, the midpoint in this particular case is M. We simply take the following. So you take the sum of the x coordinates. So we are going to have, let me use a larger bracket here. So you simply take the sum of the coordinates along the x-axis, which is x1. So you take x1, then you add x2. So you'll have x1 plus x2, then divided by 2, then comma. You also take y1, then you add y2 over 2. So this is y1, then plus y2, then over 2. So this equation will give us the coordinates of the midpoint. So it means that M will be having the coordinates of x1 plus x2 over 2, then comma y1 plus y2 over 2. So whenever you are required to find the coordinates of the midpoint, then this is the formula that you are supposed to apply. For example, suppose we are having a line. Let's consider this particular straight line here. Suppose we are having maybe this particular straight line. Then you are given that the coordinates from this particular line are, maybe let's say point A is having the coordinates of 1, 2. Then another point B is having the coordinates of, let's say 3, then 4. Then we let M to be the midpoint of this particular line. So it means that the coordinates of M will be given by the following. So the midpoint, this one will be our x1, then this will be y1. Of course, this will be our x2, then this will be y2. So x1 plus x2, we are going to have our x1 is 1, then plus our x2 is actually positive 3, then over 2. Then we say comma, y1 plus y2. So y1, my y1 is positive 2. So this is 2 plus my y2 is actually positive 4, then divided by 2. So it means that the coordinates of M will be 4 over 2, then comma, that is 1 plus 3, 2 plus 4, I'll get positive 6 over 2. Now, when we simplify, we are going to get that the coordinates of the midpoint, which is our point M in this particular case, it will be given by the following. So we'll have M having the coordinates of 2 here, 1, 2 into 4, that is 2 times. So we'll have 2, then comma, 2 here, 1, 2 into 6, that is 3 times. So this will be 3. So it means that the coordinates of our midpoint will be 2, then comma, 3. Then we also look at the last aspect on this particular topic, which is called the angle made by a line and the axis. So, of course, we have two types of axes. One is what we call the x-axis and the y-axis. So to understand this, let's start by sketching this particular, the y-axis and the x-axis. So suppose this is our vertical axis, then we are having our horizontal axis here. Then I want to let a line to run through this particular axis. So this is our x-axis. It's continuous. Then we are also having our y-axis, which is also continuous. Now, if I let a straight line cut both axes, so maybe let's say we have a straight line running through both axes this way. So we are having two angles being made here. So the first angle is this angle here, which I'm calling theta. Then the other angle here, I can call it angle alpha. So the angle theta is the angle which is being made by the line and the x-axis. So remember the distance from the point 0, 0 to this particular line. This one is what we call the change of values in the x-axis. Then the distance from 0, 0 to where the line is intersecting the y-axis. This is what we call the change in y. Now, from SOHCAHTOA, we can try to find what we call that is the tan of this particular angles that we are having here. For example, let's start with let's find the tan of theta. Now the tan of angle theta will be given by the following. Remember from trigonometry, there is this particular formula that we learned called SOHCAHTOA. SOHCAHTOA. So from this formula, the tan of an angle is equals to opposite over adjacent. Now, when we try to find the tan of our angle theta from our triangle, it will be given by the tan is opposite, then divided by the adjacent side, opposite over the adjacent side. So from angle theta, the opposite side is usually the side that is ahead of the required angle. So this is the opposite side. Then the adjacent side is usually the side joining the required angle to the 90 degrees. Of course, the 90 degrees will be here. Therefore, this side will be the adjacent side. Therefore, the tan of theta will be given by the opposite side is represented by the change in y, then divided by the adjacent side is represented by the change in x, the change in x. But remember that we said that the change in y over change in x usually gives us the gradient. It gives us the slope or the gradient of a given line. Therefore, this implies that the tan of theta will be given by will be equal to the gradient of that particular line, where theta is the angle made by the line with the x-axis. Therefore, if you want to get the angle theta, you simply take the tan inverse. You find the tan inverse of the gradient of that particular line. The tan inverse of the gradient will always give you the acute angle made by the line with the x-axis. Therefore, you can say that the acute angle made by a line with the x-axis, that is the angle theta, it will be given by the tan inverse. You just find the tan inverse of the gradient. The tan inverse of the gradient should give you the acute angle. Remember, acute angle is an angle which is less than 90 degrees. Therefore, this is the acute angle made by a line with its x-axis. So, then we can also find what we call the obtuse angle. Remember, obtuse angle is an angle lying between 90 degrees to 180 degrees. So, this is what we are calling the obtuse angle. This angle here, I can denote it by beta. So, if you want to get the obtuse angle, the obtuse angle made by a line with the x-axis, it will be given by the following. You just take 180, then you subtract the acute angle. Because remember, theta and beta, these are angles on a straight line. We know that angles on a straight line add up to 180. Therefore, if you take theta plus the beta, which is the obtuse angle, it should give you 180 degrees. Now, if you make beta subject of the formula, you'll get 180 then minus theta. Therefore, if you're asked to find the obtuse angle made by a line with the x-axis, you just take 180 minus the acute angle made by the line with the x-axis. Now, the other angle that we need to know how to find is the angle made, of course, by the line with the y-axis, the angle made by the line with the y-axis. So, in order for us to find that, let me create another page here. So, remember our triangle. This was our triangle. Let me redraw the triangle here so that we can use it. So, this was our triangle, of course, having the vertical axis, that is the x-axis, and the vertical axis, which is the y-axis. This is 90 degrees. Then we had a line joining these two axes. So we had a line joining these two. Then, of course, this was representing the what we are calling the change in y. So this is the change in y. Then this was our change of values in the x. So this is change in x. This was the acute angle theta. Then, of course, this was our angle alpha. Then this was the obtuse angle beta. Now, if we want to get the angle alpha, there are two options here. So we can say that the angle made, remember, if we want to get this angle, if you take alpha, then you add angle theta, then of course plus 90 degrees, this one should give you 180 degrees. So this is 90 degrees, this is the alpha, then this is the theta, because you know that angle sum of, that is the angle sum of interior angles of a triangle should give you 180. Therefore, the angle alpha will be given by 180 degrees minus 90 degrees, then minus the angle theta, which will give us 180 minus 90, you just get 90 degrees. then of course minus theta. Therefore, we can conclude and say that the angle made, made, not just the angle, but to be specific, the acute angle. So the acute angle made, made by a line, acute angle made by a line with the y-axis, it will be given by, so we found that the angle, which is angle alpha in this particular case, so I can use the angle alpha in this case. You just take, 90 degrees, then minus the acute angle, made by the line, acute angle made by the same line, with the x-axis, x-axis. So we can actually talk of 90 minus theta, because theta in this case is representing the angle made by the line with the x-axis. So that is how we can get the acute angle. Then if you want to get the obtuse angle, so the obtuse angle made by a line, with the y-axis, it will be given by, so we are talking of this angle here, I can call it angle P. So the angle P, it will be given by, you just take 180, you take 180 minus alpha, which is equal to 180 minus, remember the alpha is 90 minus theta, which is going to give us 180, then of course minus 90, then plus theta. So this will be equivalent to angle P, it will be given by 180 minus 90, you just get 90 degrees. So it will be 90 degrees plus the acute angle made by the line with the x-axis. So this is how you get the obtuse angle made by the line with the y-axis. Remember, obtuse angle is an angle more than 90 degrees but less than 180